Now, before going to questions, today we'll go for some theory concepts and then we'll go for the questions. So you find this Azure Traffic Manager word in many questions. So what is it basically? A traffic manager is a DNS-based load balancer. It doesn't see your HTTP traffic. It simply tells the user's computer which IP address to connect it. So before this, we had a word about Azure DNS. So Azure DNS is basically domain name service. And before that, we had a word about load balancer. So load balancer will divert your HTTP traffic to specific VM or specific service or specific container based on the load. So load balancer look inside your traffic and it will decide where to send that particular traffic. Now this Azure Traffic Manager is a combination of DNS service and load balancer. So it does the work of load balancer, but using DNS mechanism. So what Azure DNS does, so whenever you put a domain name, it will translate that domain name to specific IP address and it will divert your request to that particular IP address of that. It will go to that particular IP address. So Azure Traffic Manager is a combination of this two. So it does what it does, it doesn't look inside your HTTP traffic like load balancer. It simply tells the user's computer which IP address to connect to. So how it works, when user types a URL, Traffic Manager looks at their location or the health of your endpoints and sends back the IP of the best performing region. Then that request will go to that particular IP. So when you type the URL, it will doesn't directly translate that URL to IP address. Instead of that, it will find out the location and it will check the healthy endpoint nearest to that particular location or best performing region, and it will divert the IP address of that particular endpoint. Then that URL will be diverted to that particular IP address. So user will be diverted to that particular IP address. So key strength is it can route any protocol, not just web traffic, and has zero impact on the performance because it stays out of the data path. Now, key strength is it can route any protocol, not just web traffic, and has zero impact on performance because it stays out the data path. Now, real world examples, you have gaming server in Europe and one in the US. The traffic manager ensures a player in the London gets the Europe IP to keep their ping low. Okay. So this is the use of traffic manager. So what is Anycast? The Ncast is a networking technique where the multiple servers in a different global location share the exact same IP address. Okay. Now this is possible with a new protocol called Border Gateway Protocol, BGP. Ncast is a networking technique where multiple servers in a different global location share the exact same IP address. Where multiple servers are all living in a global location share the exact same IP address. When user sends a request to the IP, the internet's routing protocol, BGP, Border Gateway Protocol, automatically directs the request to topographically nearest server. the one with the fewest hosts. Okay. So multiple servers geographically in global locations will have the same IP address. So what this will do, so any cast will automatically direct the request to a topological nearest server, the one with a few hops there. So hops is just an computers in between, or routers or switches in between, or devices in between. Those take your request to the next hop. Now there is one more word that you might. So this word is also repeated somewhere. Now Azure front door, the global web entry point, we can say. The front door is specifically for HTTP, HTTPS service. It will act as a global entry point for your web apps. It combines the global load balancing with a modern CDN. It combines the global load balancing with a modern CDN. Fine. CDN stands for Content Delivery Network, that you already know. So we'll see what is the CDN. So how it works, it uses Anycast to bring the traffic into Microsoft Global Network at the closest point of presence POP, and it terminates SSL at the edge, making the connection to your backend much faster. So this is the global web entry point. So whenever you make a HTTP or HTTPS request, so at the first step, so Ncast will find out the nearest or closest point of presence or IP address, and it terminates the SSL at the edge. So when it connects to that particular IP address, it will terminate the SSL, making the connection to your backend much faster. So connection will be more fast in the backend. Now, key strength, it include web application firewall, WAF, and handles the dynamic content acceleration better than standard CDN. That's more faster than CDN, and it will accelerate the, we can say, dynamic content generation or handling. A global news site uses a front door to ensure that the both static page and the dynamic live scores load instantly for users worldwide. Now, in simple word, you can say, so CDN is basically designed for static content, images, static web pages, animations, CSS files, JS files. That's supposed to be directly loaded in the web browser, and web browser will process it. And Azure Front Door combines both these two together with with the help of Anycast. So first Anycast will find out the healthy or nearest closest, we can say, so POP or IP address, we can say. Then it will terminate the SSL, and it will hand over the request to the firewall application. So here we can use the web application firewall. And what this WAF will do, it will accelerate the handling of the dynamic content better than your standard CDN. Now the example is, if you look at the news site, you'll find the combination of static as well as dynamic content together. So if you want to accelerate the loading of such site, so you want to make the loading of this site faster, so we can use this particular service. So example is the global news site uses a front door to ensure the both static homepage and the dynamic live score load instantly for user worldwide. Now Azure Application Gateway. Now this is a regional specialist, we can say. Unlike the first two, this is a regional service. It lives inside a specific VNet and manages the traffic within that single region. Now, how it works, it's an application delivery controller that can look at URL path. For example, it can send images to one set of server and API to another set. Fine. So you can have the multiple servers or multiple applications. One application is supposed to manage the images, another is supposed to manage the APIs, another is supposed to manage some different things. So what application gateway do? It will check out your URL, and based on URL, it will divert your request to specific server. Now, Skeeter, it support URL path-based routing, cookie-based session affinity. So you can use the sessions of that. And it will use the cookie-based, we can say, session mechanism, sticky sessions, and SSL offloading also. What is SSL offloading? That is very advanced. That we'll see later. So real world example, an e-commerce site uses application gateway to ensure user shopping cart stays on the same server during their entire checkout process. Now, if I created a session-based application, now, and if your cart is in a session, not in database, then you need to take care that the entire cart process should run on the same server. Because session sharing across the multiple server is the, we can say, nearly impossible, toughest job. So if you want to share the session across the multiple servers, you need to create a separate server that will just manage the session. And there will be a load balancer between your state management server and the other servers of that. Now it's become very costly just to manage the sessions. So we cannot deploy a separate server in Azure. So it will be very costly option. Now, so instead of that, we can use the other application gateway. So it will take care. So if you are working with the cart and if it has some session affinity, so it will take care that the entire operation that you perform with the session affinity will be done in the same server. Right. So that is the one example of application gateway. Now Azure Cache for Redis. This is again very we can say caching concept. Now it will speed the boost. It will just boost your speed. This is an in-memory data store used to make your application incredibly fast by reducing database load. Now this is basically used for backend database. Redis cache. So how it works? So instead of asking a slow SQL database for the same data 1,000 times a second, your app stores that data in Redis. Reading from RAM is microseconds. Reading from a disk-based database is a milliseconds. So what it does? So Redis will create the cache of your repeated data. So the 1,000 users are making a request for same vacancy data. So what it does? So yeah, one query repeated for 100 times. So it will create the cache of that particular data in Redis server and it will provide that particular data from Redis itself. Now key strengths, so extreme low latency, high throughput. So a leaderboard in a mobile game uses Redis to show real-time rankings without hitting the main database every time a score changes. Right. Now the next thing that we have is Azure CDN, the content library. The Azure CDN is designed specifically to deliver static high bandwidth content like images, videos, PDFs, static pages by caching it on the server close to user location. How it works, the first time user in Australia asks for the video hosted in the US, the CDN fetches it and keep the copy in the Sydney data center. The next 1,000 Australian users get it locally. Now the key strength is reduces origin server load and slashes latency for the static files. Now, a software company uses Azure CDN to distribute 50 MB installer files so users don't have to download them from a single slow central server. So you can have any example. So CDN can have many examples of that. So on maximum time as a developer, we use your Bootstrap or we can say jQuery or we can say JS libraries or CSS libraries from CDN. So if you compare them together, in short, if you want to understand all this four together, so if four together, so traffic manager level global, front door level global, app gateway regional, Azure CDN global. Now the protocol for traffic manager, any DNS, front door HTTP HTTPS, app gateway HTTP HTTPS, and Azure CDN is used for static files. So best for traffic manager, best for non-HTTP traffic, simple DR. Front door global web apps with the security, app gateway, URL routing, and sticky sessions. Azure CDN for large files, images, and the videos. Now let's go to the questions that we left yesterday. Now, how does Azure Front Door differs from Application Gateway? Azure Front Door is a global service that uses Anycast for global acceleration. Application Gateway is regional service typically used for load balancing within a single region. And other differences you'll find in this particular table. So it's for URL routing, sticky sessions, HTTP, HTTPS, and this is for global web apps with the security. If you need WA, so web firewall. Now, what is just-in-time VM access of that? Now, it is feature of Microsoft Defender for cloud that blocks inbound traffic to the VM management ports like RDP by default. The traffic is only open for a specific user and a limited time window upon request. So just-in-time is basically one mechanism or one feature that we can use with the VM access. So that will help you to allow the VM access. And what VM, this particular feature will do, so it will block the RDP port for, we can say, Windows and the Linux. So for Windows, it's 33 at 9, and for Linux, we have 22 SH access, we can say, in Linux by default. So traffic is only open for specific user. So using this just in time, so we can open the traffic for specified user for limited time window upon the request of that. Now here, so how do you handle the state in the multi-instance web app state management, where multiple instances of web app is running? To ensure the statelessness, I would move the state out of the local VM or container into a distributed cache like Azure Cache for ADS or database like Cosmos. Or you can create a separate state management server. That is very costly options. So if you have the multiple instances of web applications and load balancer support to divert the request to specific instance of application based on the load, then how we can share the state? So you can move the state from your local VM or container into a Redis cache, or you can put it into a database. Now, since session is required continuously and it's will have a huge topic, so we'll prefer to use the Cosmos DB. You can also use the SQL Server DB to store the session in a database of that. Now, questions. So, what is the sovereign, we can say, cloud in Azure? Now, there are physically isolated instances for specific government or regulatory needs. Now, Azure has that particular capability. So, if Indian government says we want to use the Azure, but our we can say Azure, we can say services or Azure everything should be server. So what it means, it will be isolated from everything. It should not be connected to any of other, we can say, things of that. Now that may be needed for government or regulatory policies or legal policies with that. So Azure government, yeah, so we already have one cloud called Azure Government US and Azure China. So Azure China has its own, we can say, so on cloud with that. Now, how do you automate the deployment of 50 identical VMs? I think it is in a question. Now, so you would use the ARM templates. You can create one template and you can create the 50 copies of that template and you can run them directly. Bicep, so Bicep को भी use कर सकते हैं. Bicep is advanced concept that we'll see in second session with logic apps. Now Terraform, so there's one more option. So you can also use the Terraform to define the infrastructure as a code. So we can say so Terraform enables you to define the infrastructure as a code. You can write the code to create the infrastructure. And you can combine this with a virtual machine scale sets, VMSs, for automated scaling and management. If you need scaling and management together, if you don't need VMSs. Now, what is the purpose of app service plan? So whenever you create app service, it will create an app service plan also. Now, app service plan defines the physical resources, CPU, RAM, and storage that a web app uses. Now, multiple apps can run the same plan to save the cost. While creating a app service, so you'll find this particular option, so app service plan, and this will help you to use the same service plan across the multiple instances of your web applications. So multiple instances of your web application, it will help to share the CPU, RAM, and the storage. Now explain the difference between the vertical horizontal scaling. ये तो काफी easy है, so ये हमने शुरुआत में देखा था. In vertical scaling, so we add on more power, more resources like CPU, RAM to existing machines or existing service. And in horizontal scaling, so that is called scale out. Now means adding more instances of a service or more machines to the pool of that. So we'll create the multiple copies of the machine or instances of that in the pool. And in vertical scale, we upgrade the resources of that. Now, how do you troubleshoot 502 bad gateway on application gateway? So how do you troubleshoot 502 bad gateway on the application gateway? I check the backend, we can say health in the portal. If the probes are failing, I verify the backend server is running and the energy allows the traffic from app gateway submit and the certificate if HTTP is valid. So to check 502 bad gateway, on the application gateway, we will go for the backend health service, backend health portal, and there we'll verify whether the backend server is falling or NSG is creating some problem in app gateway subnet, or there is some issue with a certificate of that. Now, what is Azure Blueprint? So it allows the architects to define the repeatable set of Azure policies RBAC ARM templates to ensure new subscriptions comply with the organization standards of that. The Azure Blueprint is the, we can say, a box, a package box, which contains the Azure policy, the RBAC, ARM templates, everything. And when new subscription created or new office of the company opened or new client of the company opened, and if it want that same thing with that, so we'll use that particular box. We'll deploy that box. It will deploy everything with that, and that is called Azure Blueprint then. Now, if you have a web app that needs to store millions of small JSON documents with low latency globally, which DB do you choose? So simple question is, so Azure Cosmos DB, it's multi master application, low latency, make it ideal for global JSON documents of that. Now, what is different between hot, cool, and archive storage tiers? Now, hot is the frequent access, so high storage cost, lowest access cost. Now, cool is the data stored for 30 plus days. Archive is for long-term backups, lowest storage cost, highest access cost. Data is offline. Now, there is one small confusing question. Cold start in Azure functions. So what is cold start? Cold start is basically a delay that occurs when function is triggered after being IDF. The platform need to spin up the container. It can be mitigated by premium plan or app service plan, always on. So every Azure function has some, or we can say by default cold start time. And in that time, so your container will be spin up before executing the other function of that. And you can avoid this particular thing using premium plan or app service plan of that. So you can keep it always on. So you can keep the Azure function always on because we had a word about Azure function. Azure function just the code residing. When triggered, will execute it. Now, other option that we can use always on. If you want to avoid this cold start time period or delay with that. Now, what is an Azure private link? So it allows you to access Azure PaaS service like a SQL or storage or a private endpoint in your VNet. The traffic never leaves the Microsoft network, increasing the security. So Azure private link is, we can say, a service or Azure mechanism which will help you to access platform as a service from public network, right? Platform as a service. Right. So in which when one resource talk to another resource or any private endpoint, it will not go outside the we could say private network, sorry, Microsoft network with that. So it will keep the entire traffic inside the Microsoft network, increasing the security there. For example, suppose we have a web application app service and we have SQL Server database running on a VM or somewhere else outside the app service. So if we do not use the private link mechanism, so web app traffic may go to SQL Server through from a network outside the Microsoft network of that. Now, if we connect them using Azure private link, so entire traffic will be in the Azure network of that. Now, how do you monitor the health of your entire Azure environment? We can use Azure Monitor. We can use Matrices Log, Application Insights, so Azure Health, or we can also use Azure Advisor to check out what is happening inside your Azure environment. Now, what is hub and spoke? I think we had a word about this. Hub is a central VNet containing shared resources, whereas the spoke are the separate VNets for different workloads that peer with the hub. Now, this centralized security reduces the cost of that. Now let's have some scenario-based questions. So if your company has a ASP.NET Core application currently running on the IaaS server on premises, the company wants to move it to Azure with a minimum infrastructure management. So which Azure service would you choose? So ASP.NET Core application आपके पास IaaS वेब सर्वर ऑन प्रीमाइसेस में है और कंपनी क्या करना चाहती है मिनिमम इंफ्रास्ट्रक्चर मैनेजमेंट के थ्रू उसको शिफ्ट करना चाहती है अजूर में तो व्हाट विल डू सो विल ऑलवेज प्रेफर टू यूज अजूर ऐप सर्विसेज यूज अजूर ऐप सर्विसेज में क्या है सो प्लेटफॉर्म एज अ सर्विस नो ओएस मैनेजमेंट नो रन टाइम installation configuration update patching now you just need and it has support for ASP.NET Core also now built-in scaling and monitoring is also possible here. Now, suppose, so second scenario that we have, your application receives sudden traffic spike during sales events. So how do you ensure that application scales automatically? Now, so we can use the features like app service. Other app service will host that particular application in app service if such is the we can say requirement of your application. Or we can, if you use the VM, so we'll use the VM scale sets or we can also create the containers. In the containers, we can do the, we can say horizontal scaling, where we can run the multiple instances of containers and we can manage them using Kubernetes, or we can say Azure Container Manager. So it automatically increases the instances during the high traffic with that. Now, scenario, so your web application must remain available even if one data center fails. How would you design this architecture? So availability zone, we had a word about this. Multiple instances of app service running in different, we can say availability zone. Azure load balancer or Azure traffic manager, we can use this. This provides the fault tolerance of that. Now, so your application store millions of images and videos. So what storage you will use? A simple question. So we can use the blob storage for that because it's for unstructured data, large files, scale storage. Now your system needs to process orders asynchronously between the microservices. So what we can do, so we can use the queuing mechanism, so Azure Queue Storage, or we can use another service that is mostly popular for microservices, that is Azure Bus. So which Azure storage service would you use? So we can use the Azure Queue Storage or Azure Service Bus. Now queues allow services to communicate through message-based architecture. Now, your application needs to store large volumes of a simple structured data with a fast lookups and low cost. So if your application needs to store large volumes of a simple structured data with a fast lookups and low cost, so which service you are going to use? So Azure Table Storage. So Azure Table Storage having very fast lookup of that, and it can store the large volume of data. Now it is NoSQL key value store optimized for scalability. Now, so your company has 50 small databases with predictable uses. So sorry, unpredictable uses. What we can do? So to reduce the cost, we'll use the elastic pool. So for Azure SQL, we have option called elastic pool, where we can run the multiple databases in shared compute resources, and they can consume those resources with that. Now your customized DB application is slow when querying data. So could be the problem? So you are using a customized DB, and when you query it and it's responding slowly. So what could be the problem? So where we can check the possible causes will be poor partition key selection. So that may be the first reason that you need to look out. Now the partition key is selected properly. So I had already told you. Now insufficient RUs. There might be the possibility that that query needs more RUs and you have less RUs available. Now missing indexes. So if indexing is not done properly or indexes are missed, then again it will slow down the result of the query. So choose good partition key for best performance plan. Now developers need to access to other resources but should not have full admin rights. So your developer want to access the Azure resource, but we do not want them to have the full admin rights. How do you manage the permissions? So we can use the RBAC and assign the role like, so we can assign the role like reader. So in RBAC, we have the options like reader or contributor. So here we can assign the role contributor. We'll assign the role contributor that. Fine. Now, so your Azure VM should not be accessible from internet. So how would you secure them? So private IP address. First thing that we'll do, we'll use the private IPs instead of public IPs. NSG rules. So we can create an NSG rule to block the traffic out from outside the Azure. So if you don't want to use the IP address explicitly, we can use the private endpoints, or we can we can say Bastion service, also host for access. So we can use this Bastion service. We can say Bastion service to host access. Bastion service for the host access of that. Now we had heard about this. So Bastion will help you to create the private tunnel, even though if you are on premises, talk to your, we can say Azure cloud there. Now you want to allow the HTTP traffic, but block all other traffic to your VM. So what we do, we'll go to the NSG and we'll open only port 80. So we'll not open any other port of that. And we'll apply that NSG of that. Now your application randomly fails and you need performance insights. So where you look out for, so we can do that in an application insights. In applications insight, we can say request monitoring, performance matrices, and error tracking with that. Now you want to receive the alerts when CPU uses exceeds 80%. So well, what you can do, so you can configure it in a Azure monitor alerts with that. So in alerts, we can configure the alerts, monitor alerts with that. Now you want to reduce the cost of long running VM. So what are the options that can reduce the cost? So use reserve instances. So reserve instances are more cheaper as compared to your regular instances of that. They provide the discount for long-term uses. Fine. So if you have VM that is supposed to be executed for 24/7 for 1 year, then instead of using your regular VMs, it's always better to use reserve instances. That will definitely Microsoft will provide you the discount on the reserve instances of a VM, and that can be used for long-term uses. Their application is packaged in Docker container. So which Azure services can run containers? So we already know that we can use ACI, ACA, and Azure Kubernetes services you can use. And we had discussed the differences between them. Their application must support millions of users globally. So what architecture would you use? So multi-region deployment. So Cosmos DB global replication, Azure CDN. for content, we can say static content, and traffic manager. So to choose the specific, we can say a route for the traffic with that. So your primary region goes offline. How do you ensure your users are redirected to secondary region with a zero manual intervention? So I would implement Azure Front Door or Azure Traffic Manager. So Front Door is preferred for web apps as it uses, we can say, Anycast to route the traffic to nearest healthy, we can say, backend. I did configure the health probe so that if the primary region's probe fails, the traffic is automatically fed over to the second region. So we can use the Azure Front Door or Azure Traffic Manager. So you have these two choices there. Now you need to migrate a legacy app that cannot be refactored for a pass. How you ensure 90.90%? I think this has already been discussed. So would you deploy the VMs across the availability zone? So this ensures that even if the entire data center fails, the VM in another zone keeps app running. So I would also use standard load balancer to distribute the traffic up across the zones. Now the client wants 25-minute probe. VMs cannot talk. So, so the client wants 25-minute, we can say RPO, recovery point objective. What is your backup strategy? So I would use Azure Site Recovery ASR. Now ASR will see that, we can say next session. Now ASR provides continuous application for VMs with RPOs as low as seconds to minutes for superior to standard daily backups. Usually you have 24-hour RPO then. Now, I think this question you don't need right now in the course one. Now, it's a scenario. 2 minutes are paired, but the VMs cannot talk. What you first three troubleshooting steps of that? Check where the pairing status is connected on both the sides. Check the NSG network security group rules for both subnets to ensure the specific ports are allowed. Check the effective routes on VM's network interface and IC to see if the UDR is overriding the pairing. If you create the custom route of that. Now you must allow the vendor to access the VM via RDP, but your company policy forbid the public IPs on a VM. How do you solve this? So answer, I would deploy Azure, we can say, Bastion service. This allows the secure RDP access directly through Azure portal using SSL. So port 443, eliminating the need for public IP on the VM or complex VPN setup. An app needs to access SQL database, but the security team forbids the storing the password in the app setting.json. So what we'll do, so I would use manage identity, enable the system assigned identity on the app service, grant the identity, SQL DB contributor rights of that, and the app that connects using the Azure AD token, requiring 0 passwords in the code of that. Fine. So we'll use the managed identity. Managed identity is nothing but one instance of that particular identity, which will securely connect through, or we can say internally without explicit uses of the password, or we can say key, or we do not need to configure it inside the code. Their app service scales out to 10 instances during the spike, but the users are still saying 503 service unavailable. Why? So the answer is the scaling the computes isn't enough. The bottleneck is likely in the database, or we can say SNAT port execution, or DTU limit, or dependency like third-party API. So I would check app insights to see if the dependency call duration has spiked with them. Now you are running a batch job that requires 100 VMs for 2 hours every Sunday. How do you minimize the cost? So I would use Azure Spot VMs since batch jobs are usually interpretable, and Spot VMs offer you 90% discount compared to pay-as-you-go prices. Now, a production VM were deleted. How do you find out who had deleted that and when? So for that, you need to go to the activity log of your subscription, and on a specific resource group, I will filter the delete virtual machine operation to see the caller ID, email ID, and the exact timestamp of that. So if you are migrating 2 TB of, we can say, SQL database to Azure, the client wants less than 30 minutes of downtime. What would you use? So we'll use the DMS. So Azure DMS. So Azure Data Migration Service with an online migration configuration. It keeps on-premises Azure DS in sync via log shipping, and you only perform a quick cut over of the end. Fine. So quick cut over at the end of that. Now, if you use this DMS service or this DM online migration with option online migration, what it do? So it will help you to migrate the on-premises your database to Azure database of that with syncing. So your application with sync mechanism of that, so that it will not lose any data. So that it will not lose any data, and you can do the cut over at the end of that. Fine. So quick cutover at the end when migration is finished with that. How do you protect against the man in the middle attack for the data moving between your on-premises office and the Azure? So I would implement site-to-site VPN, which uses IPsec and IK encryption, or we can use the express route with the MACsec encryption. So this ensures data is encrypted as it travels the provider's network with that. So I will not suggest you to answer this question because it will generate many other questions like what is IPsec, what is IKey encryption, what is MACsec, what is difference between the IPsec and IKey encryption that. Fine. So it's on your own whether you want to take the risk for this question. So you can take the risk with that. Now these are the few questions that we have here. Fine. So इसको यही छोड़ेंगे आज